No, I didn't.
You said don't get my
Considering
other
he was
time.
all
You
wild.
promised.
I didn't promise.
You
I
promised.
saw your pinky go up.
Everyone just
We have
thought
an
you were
imaginary
gonna have
contract
it.
here saying that like you weren't gonna do it.
He said an outing about like
2 months ago.
I did not know that.
Alright. Oh, I need a calculator. Okay. We are talking about critical points today. This is a pretty easy thing today. So we want to be able to identify critical points, extrema, and increasing and decreasing intervals. This is like easy math here. Okay. Critical points are points where the graph changes its direction or its shape. Okay. Critical points are points where the graph changes its direction or its shape. Extrema are points where the graph changes direction. The function has a maximum or minimum value. Sometimes we call them maxes or mins, or sometimes we say relative max or relative min, or absolute max or min. At these points, and then the point of inflection is where the graph changes its shape, which I'll talk a little bit more about here, but not its direction. So when I'm looking at this particular example here to the right, you can see pretty clearly that we have a nice little smooth curve here. But you can see if we start on the left side of the graph, we are going uphill, 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 and we reach the maximum of the mountain. Okay, yeah? Top of the mountain, called maximum. It is also called a relative max. It's called a relative max. I'll talk about that in just a second, actually. We turn around. So now we're changing direction. So because we're changing the direction and now we're going downhill, that is an extrema, okay, where we're changing direction. Now, when I look, we have this point she has highlighted here, point of inflection, it's called, right here. This is a point of inflection. This is actually wrong, but that's okay. I'll go with it for now. We have this shape here going uphill to downhill. Uphill to downhill. We call this shape concave down. Concave down. Sort of scooping down. Does that make sense to you? Like a cave is a concave downward. All right, so like a parabola we would call concave downward. Let's test this one, okay? Versus a shape that's going scooping upward like this. This we would call concave upward, okay? So, yeah, it's so tricky, right? Concave down versus concave up. And so here, this first part, our shape of the curve, we would call this shape concave down. But then over here, this side changes, and now you can see the shape is concave up. So it changes shape right here. You can see this is concave up. So I'm abbreviating that CC up, okay? And so here when we change from concave down to concave up, that is a point of inflection. Ladies and gentlemen, welcome to your very first calculus term. Okay? That is a point of inflection where it changes scoop. Okay? It's going concave down and concave up, or vice versa. Okay? And then as we're coming downhill, we reach this minimum, the bottom of the valley. Okay? That is a relative minimum. And then the graph continues to grow. Now here we go. This graph continues to go how far? Up. Forever to the up. Okay? It goes up forever. Does it have an absolute maximum? Is it ever going to get there? Absolutely? No, it's never going to reach it. That's going on forever. That's what forever means. So you can't ever get there. Okay? This does not have an absolute maximum. This is a relative minimum and a relative maximum. We can talk about absolutes in just a second. So let's talk a little bit more about relative versus absolute extrema. All right, a point with the greatest value compared to the points around it. The very nearby points, not all the points, just the ones close by, is called a relative maximum. And so you can see right here, we have this relative max in this picture to the right. We are looking at the points just in a little tiny neighborhood. That's a mathematical term as well. It's called a neighborhood. We're just looking at a small little set of numbers. And in that small little set of x values, we have a relative maximum. Versus the point with the greatest value, the greatest y value over the entire domain of the function. So when I look at this nice like shape here, we have our, right here, the very highest y value is our absolute maximum. William and Lucy. You need them outside? Or?
It's just a quick question.
Oh.
Are you guys doing DPA? So you're guessing.
Okay. All right. So this is an absolute maximum because it is absolutely the highest y value of the entire graph. Does that make sense to you? It's absolutely the highest. All the other y values are under it, correct? All right. So it is the highest y value. That is an absolute maximum. Okay. It is the highest y value. All right. Then a point with the least value compared to the points around it, right here, this little guy right here, compared to the ones close by, he's the relatively smallest y value relative to the others close by. So we call him a relative min. Versus this guy right here, the point with the least value, he is absolutely the smallest y value right at the bottom of the curve there. Does that make sense to you? All the other y values are higher than that, correct? So this is the absolute minimum, which is pretty easy to see, I think, usually. I'm going to strangle that to death. Okay, so for these couple of examples, we are going to give the coordinates and classify the extrema for the graph of each function. And we can use our graphing calculator to approximate as needed. Oh, okay. You're going to need your graphing calculator. So they gave us the function here. And we want the extrema. I want to know, is it a relative max or a relative min? Is it an absolute minimum? What do we have in number 1 here? Yeah, right here. What is that ordered pair? 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. 4, negative 5. This is an absolute minimum. Why is it an absolute minimum? It is the absolutely lowest one. There is no other y value that could be smaller. Sorry, you can't see that. There you go. Okay. Let us look on our calculators for this one. So I'm going to go to my calculator, win it out, graph it out. Negative x to the 4th plus 4x squared minus 2x minus 4. I'm going to put that in my graphing calculator. And go ahead and zoom standard. Zoom standard. All right. So we have a couple of points here. I see this point right up here. What would you call this point? The absolute, absolute max. And we want to approximate that. This picture is kind of okay, but we can actually use the trace feature on our calculator, and we can trace to that point and just kind of get an approximation there. to 2 decimal places was going to work for us today. And so I got an absolute max here at negative 1.51, comma 2.94. So there's my absolute max. Just using my calculator to trace and march to that. All right, let's see. Then, what would you call this point down here at the bottom? A relative minimum. Yes, very good. It's relatively the lowest point compared to those next door to it. I think that's pretty good, about right there. So I'd call that a relative min. Relative min. And my calculator is giving me, let's see, about, yeah, that's 4. Okay, like negative, 0.30, and then maybe negative 4.24. Relative minimum, something like that. Oh, maybe 4.25, but that's good. Yeah, it's probably okay. We're just approximating anyway. And then, what would you call this one right here? Another relative maximum. Very good. So very easy, not too hard. All right, there's our relative maximum. Oh, that looks a little higher. Oh, yeah. Okay. All right, there we go. My relative max is roughly at 1.21 and then negative 2.71. There we go. These are just approximating. I can't remember now if I'm going to have to look at the Dutch math to know if I need you to be more specific than that. Okay. Questions on absolute and relative minimums and maximums. It's really easy, right? Okay. Let's look at number 4 really fast here. We have a relative maximum right here and a relative minimum. Easy to identify. Super easy, right? Where is there anything else going on? Any other critical points? The inner circle called the, what is it called? The point of inflection? Yeah, point of inflection. Okay. Yes, we do have a point of inflection, which is, where would you say it is? 0.3. Yeah, right there is a nice little point of inflection. It's one of them. There's actually more. But I'm just going to go with this for now because you have not had enough calculus yet. So, okay. But you can see our graph is changing from concave down to concave up, sort of. Okay. Oh, that's the first thing that I am not happy about. Okay, sorry. Okay, so that's good enough for now. Okay. Easy. Increasing and decreasing. Moving from the left side of the graph to the right side of the graph, a function may increase, decrease, or remain constant on intervals. So on this graph to the right here, as I move from the left side, I am increasing on this first interval. Now, when we talk about the interval, I care about the independent variable. Our independent variable is the x-axis. Everything we care about is an x, okay? On the x interval, this graph is increasing. How far to the left does this arrow go? Infinite, right? So this goes all the way to negative infinity. Negative infinity. All right? And then we're increasing all the way to what x value?
-1.
-1 right here. We're stopping right here at -1. So we are increasing that whole little interval. Our graph is going uphill. And then, what would you call this flat section? It's the constant. It's constant. It is unchanging. It's not changing at all. It's totally the same. Every single, what x interval is that constant section? -1 to 4. Yes, from -1 to 4. That is the x interval where our function is constant, a constant y value. And then, what is our function doing after that? It's decreasing. We're going decreasing. Yeah, decreasing from 4 on the x-axis all the way to all the rest of the x's. We're going downhill. So from 4 to infinity, we're decreasing. That's nice. It's super easy, yeah? Super easy. All right. So let's look at a couple of these. And then I'm just going to change your assignment, I think, and then that'll be super easy. Okay. On this number 5, where is our increasing interval? Right here from what x point? 3, right here. From 3 to infinity, we are going uphill. And then negative infinity to 3. We're going downhill. This whole thing, all of this is going downhill. You good? Okay. Ooh, trickier. Number 6. This section of the curve, was that going uphill or downhill? Oh, this whole thing is downhill. Decreasing. And then we have this other section. What's that doing? Decreasing as well. So what's the decreasing interval here? What is in between it? That is negative 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, negative 5. There is an asymptote there, a break in the function, a break in our curve. And so our decreasing interval is from negative infinity all the way to negative 5. But then we pick up on the other side and we're decreasing from negative 5 to infinity. So that's a little union one. What about number 7? Just increasing. And increasing from, negative infinity to positive infinity. There is no decreasing interval. All right. And then this one is, I don't know, that doesn't look very good either. We're going to stop there. You get that? Are you good? It's pretty easy, right? Not hard? Okay, excellent. We're going to stop there. I'm going to adjust your Delta Math assignment. And so that should be